Hey, this is Mr. C, and this is Unit 1, Lesson 5, Ready, Set, Go. Okay, number 1, define a polygon. A polygon is a closed figure made from line segments. So no curves. Okay, so you make something out of straight lines, all connecting, that is a polygon. So some examples of polygons based on the number of sides. If you have a three-sided polygon, well, we know what that is. That is called a triangle. A four-sided figure is a quadrilateral. A five-sided figure is a pentagon. A six-sided figure is a hexagon. A seven-sided figure is a heptagon. An eight-sided figure is an octagon. A nine-sided figure is a nonagon. And then a 10-sided figure is a decagon. In case you were curious, there are two more that we could probably add on here. A 11-sided figure is called a hendecagon. And a 12-sided figure is known as a dodecagon. And there's plenty of names after that, but after 12, we're just going to just give the number and then write gon in. So like 13, we'll just say 13 gon. 20 would be a 20 gon, and so forth and so forth. Okay. All right. Number 3. One quadrilateral with special attributes is a kite. Find the geometric definition of a kite and write it below. So, geometric definition of a kite is a quadrilateral with two pairs of consecutive congruent sides. And what that looks like, well, if I have one or two sides here, try and draw it as best I can, and those are the same length, and then I draw another pair like this. And those are equal. That is a kite. Okay. Let's draw a kite and show reflective symmetry. So to show it, let's actually go back to our GeoGebra model here. Here's our kite. And the only lines of symmetry we would have is right down through the vertical like that. That's the only way we would have a line of symmetry. So there is our kite. And just a single line of symmetry. The diagonals, one of which is on our line of symmetry, and the other is not. Is there any rotational symmetry for a kite? Nope, no rotational symmetry. So, no rotational symmetry. Okay. Consider quadrilateral such parallelogram, rectangle, square, rhombus, and kite for the following questions. Are lines of symmetry also diagonals for any given polygon? Well, we've seen a couple. The rhombus and the square and rhombus, square, and that's it. Okay. So for number 7, are all diagonals also lines of symmetry for any given polygon? Well, no. The rectangle and a parallelogram, those are not. Diagonals do not work as lines of symmetry. Which quadrilaterals have diagonals that are not lines of symmetry? Okay, so we just listed a couple of them. So, rectangle, so diagonals do not work for rectangle for lines of symmetry, and the parallelogram also does not work. For question number 9, do parallelograms have diagonals that are lines of symmetry? Only in a special case. So only if the parallelogram is a rhombus. That's the only time that we'll have diagonals be lines of symmetry. Okay, for problems 10 through 12, find the equation of A, a line parallel to the given line through the indicated y-intercept, and B, of a line perpendicular to the given line through the indicated y-intercept. So if it is parallel, remember, same slope. If it's perpendicular, opposite reciprocal slope. So on our equation number 1, we can see that our slope is 4. So for A, our equation is going to be y equals 4x, but this time with a different y-intercept, it's going to be at -7. So 4x minus 7. Okay, then perpendicular. So the slope, if we flip 4 and change the sign, we're going to get a slope of -1/4. So that's our new slope for the perpendicular line. So -1/4 x, and then the same y-intercept of -7. Okay, we have a table of a line, and we're going to create an equation of some lines that are parallel to that. So let's see, First, we need to figure out what our slope of our line is. So let's figure out what's going on in the y. We are going down 2 each time. And our x's are going +1 each time. So our slope is equal to -2 over 1, or we could simplify that to just -2. So a line that's parallel and goes through that y-intercept of 0, 8, well, our equation is going to be y equals -2x plus 8. Perpendicular, we're going to flip that slope and change the sign. So our new slope is going to equal +1/2. So our equation would be y equals +1/2 x plus 8. Question 12. Okay, this time they give us a graph. So we need to find the slope of this graph. So let's find a couple of crossing grid points. So maybe there and there. So that's going down 1 over 3. So my slope is -1/3. If I'm parallel, it's going to be the same slope. There's my y-intercept. So my equation becomes y equals -1/3 x minus 9. That would be a parallel line. A perpendicular line, we need to flip that slope upside down and change the sign. So that would be a slope of +3 over 1, or just 3. So our equation becomes y equals 3x, and the same y-intercept, so -9. And that is it for this Ready, Set, Go.